Hello, we are Group 4, and our project is Heart Disease Classification. I'm Po Chen, and we have Ishita, Isha, and Tingyun Zheng. This is our agenda, and we will go through them one by one. First, I would like to mention that 655,000 Americans die from the heart disease each year, which is about 1 out of 4 deaths. And every 40 seconds, one American will have a heart attack. So we are inspired by these informations. So the problem is that this high amount of heart disease case will put pressure on the healthcare resources. Then we identify the two stakeholders, which is healthcare professionals and the patients. Also, we provide 2 analytic solutions, and we will elaborate them later. We have 2 constraints, which is we only have 14 variables for now. And the second is that our dataset is relatively small for now. If we want to collect more data, it will cost a lot. Our business benefit has long run and short run. The short term is that we use EDA to identify patterns and train HCP staff to check for their signals in patients. And then we can do the preliminary detection from diagnosis, can identify the high-risk patients and allow them for optimal resource allocations. And in the long goal, we can replace the manual HCP evaluations with the tool predictions. So we define the problem that we analyze the data with 14 factors, and then we predict the likelihood of heart failure level. We assume that existing diagnosis data will be a key indicator in the predictions. And in our successful metrics, we use accuracy and interpretability to identify our model. We use 2 kinds of analysis, which is descriptive analysis and the predictive analysis. And then we use R to do all the programming. Okay, so we pull data from the UCI machine learning lab, and then we do the data cleaning, change the variable from a question mark to an A value, and we drop the outliers. Finally, we remove the missing values, and we transform the target variable into binary category, which is 0 and 1. And then we can do the EDA analysis. And I will hand it to Tingyun to demo the EDA part.
Now, let's demonstrate our Shiny app. There are 2 parts. The first part is descriptive analyst. The second part is predictive analyst. In our descriptive analyst, there are lots of charts. For this chart, it represents ages. So we can type any ages that we want to try. So now we have 40, and if I try 100, so we can see the relationship. People who are 50 years old to 70 years old had higher chance to get heart disease. And the next one is gender. Let's click 2 boxes, and we can see that male, they actually have higher chance to get heart disease as they have almost 50% of proportion of heart disease. And for this chart, it represents the resting blood pressures. The resting blood pressures, when the number is lower, there are actually no cases. But if the number gets higher, we can see that people who have higher resting blood pressure have higher chance to get heart disease. For this chart, it represents the chest pain type. There are 4 types. For this 4 type, we can see that asymptomatic, they have higher chance to have got heart disease. For this chart, it represents the serum cholesterol. So we also scroll the numbers from lower to higher. So we can see this trend. People who have higher serum cholesterol also have higher chance to get heart disease. For this chart, it represents maximum heart rate achieved. We can also change the number to lower to higher, 150. And we can see that people who have maximum heart rate achieved higher then get higher chance to get heart disease. With this trend, it's increasingly with the numbers.
Moving to the chest pain type. So as we can see, when the chest pain type, the FPS range is less than 120 and greater than 120, we have an equal proportion of people having a heart disease. So we cannot, the chest pain type is not a good indicator for a physician to say if a patient can have a heart disease or not. The next is the heart disease versus rest CEG. So as you can see, when the rest CEG report shows probable or definite left ventricular hypertrophy, we can see we have a higher proportion of people having a heart disease. And when that report is normal, obviously we have a low proportion of people having a heart disease. And when that report shows ST wave abnormality, we have a very high proportion of people having a heart disease. Coming to the next part is the exercise and IGNA. So if a patient is reported an exercise in IGNA as yes, there's a higher proportion of people having a heart disease. So it's a good indicator in that terms. Coming to the slope segment. So when the slope segment tends to be flat or upslope, actually downslope, we can see equal proportion, or in case of downslope equal proportion, and in case of flat a higher proportion of people having a heart disease. And when that slope segment is upslope, as you can see, there is a less chance of a patient having a heart disease. Old peak and heart disease. As you keep increasing the range of the old peak, as you see, there is a higher probability of a patient having a heart disease. THAL report. When the THAL report is normal, you have a less proportion of people having a heart disease, versus when the observation shows a reversible or fixed effect, we can see we have a higher proportion of people having a heart disease. And when, as you see, when we keep increasing the CA number, that the chance of heart disease increases.
During the model building phase, we ran multiple linear and non-linear models along with single and ensemble algorithms in each category. To identify and shortlist candidate models, we used ROC-AUC score to ensure not only good accuracy but also good recall for both the classes. With these trials, we shortlisted logistic regression and XGBoost as our candidate models. The final model selection was then done with an additional criteria of model interpretability. Owing to the sensitive nature of this application, we believe model interpretation for HCPs will help us garner confidence in the model and make implementation easier. From logistic regression results, we inferred that 5 variables are largely driving the chances of having heart disease, where 3 are diagnosis-related factors and 2 are related to patients' existing demographics. However, this information cannot be used in a conclusive nature as our training data set is currently very small. In order to remediate this, we allow patients to input data for all the 14 variables, which can later be used to build larger training data sets. Now, let us look at our R-Shiny app to get the predictions. Here, as you can see, we have different fields for all the 14 input variables, starting from age, gender, type of chest pain, and other diagnosis factors. Let us see what prediction we can get out of these base values. So firstly, if we use these base values, the patient has a 50% chance of having a heart disease. Now, let us change the gender and see how these chances change. When we change the gender to female, we see the probability of having a heart disease falls drastically, which means that males are more susceptible to getting this condition. Let us change the number of blood vessels that are colored by fluoroscopy, which is another important indicator. And this again increases the chances of having a heart disease. So as you can see, this application can allow to get real-time predictions for patients and can also be used in preliminary screening. To conclude, we would like to say that there are we would like to say that there are many future improvements that can be done on this application. One is to get more specific labels for the heart conditions. We can also use a larger training data set, and we can provide a summary chart for patients to motivate them to improve their health condition better. Our learnings in this project have been really immense, and we learned how to design the analytical process from a business perspective while keeping the final end stakeholders into consideration. And we also gained an end-to-end experience on applying R in EDA, predictive analytics, and application development. With this, we would like to conclude and thank you all.